In this video, we're going to be talking about modeling with quadratic equations. So let's look at the words. What is modeling? Well, model is just a representation of something. But a mathematical model, I found two definitions that I like. It's a description of a system using math concepts and language, or a method of simulating real-life situations with math equations. Now, you may disagree with me, but I find this extremely cool how by making some little calculations on a piece of paper, we can actually predict something that's going to happen in real life or describe something in real life. Now, there's many very in-depth mathematical models. We're going to be dealing with quadratic models. So, mostly stuff that you can throw without much of an effect on air resistance or curveballs or anything like this. But because everything that gets thrown will make a parabola, it's useful for this. So, fortunately for us, there are two types of quadratic models. We got the ones where you can find the zeros and a point, and the ones where you can find the vertex and a point. And if you have that information, you can get an equation. An equation is going to be a little mathematical gizmo that will give you every point along that parabola. If you just tell it the time or the horizontal distance, then you plug it into your calculation and it'll give you your y, or the height. So any equation is just that, a mathematical gizmo that will give you a height if you give it the horizontal distance, or other way around. If you manipulate it and if you take it the height, you can figure out when that happened. Okay? So how does it work? Well, if you can get the zeros, then you're going to use factored form. And all you're going to do is you're going to plug in your s and your t as your zeros, here and here, and your x and your y from your point here and here. So all you got left to find is your a value, because that's the only thing you do not have. So once you have your a, you plug everything back in, and you have your model. You have your factored form. Or in this case, if you have vertex form, well, the vertex is your h and your k, so you plug in your h and your k. Your point that you have, an extra point in e and that point, x and y, you plug it on your y and your x. And all you are missing is your a value. Therefore, when I ask you to model something, basically you just need to find the a value and then plug everything back in. So let's look at two examples. Let's say they give us a graph like this, in which we can tell that the zeros are -1 and 3. So s and t are -1 and 3. And we can tell one point, and this happened to be the y-intercept. So they only give us a 2, but we know that because it's the y-intercept, it's going to be 0 and 2. So because they gave us the zeros, we're going to go with factored form. And that's what factored form looks like. And let's plug things in. So my y is -2. My x is 0. My s is -1, so I'm going to put it between brackets. And my other 0, 3, my t is 3. And now I need to do a little bit of bed math to figure out what my a value is. So let's see, I got -2 is equal to a. Now I have 0 minus -1, so it's just +1. And 0 minus 3, it's -3. So basically this is -2, and this is -3a. If I divide both sides by -3, I end up having 2 divided by -3 is equal to a. Therefore a is equal to 2 over 3. And I found my a value. Now, that's not the end of the question. The question was to model it, so I got to give it the equation. And I don't have a lot of room, but I'm going to try to squeeze it in here on the side. And that is my y is equal to 2/3. That was my a value. And now I need to give it my x minus something now. X plus 1, because it's minus, and x -3. So when we give the final answer, we always leave the y and the x, because the y and the x will represent all the points along that parabola. So the 1 and the 3 will be the zeros. They will not change. The shape, the 2 over 3, that will not change either. But the x and the y will change as I'm going along. So when I give you my final answer, we'll have the y and the x. I will not use this point anymore. Make sense? So that was for modeling. Let's see if we get a word problem. This will get more interesting. Now, remind me in class to tell you a story about the Mayan ball game. But let's say they give us this. In the Mayan ball game, a player hits the ball at the height of 2 meters. That's pretty high. The ball reaches a maximum height of 5 meters after 1 second. And usually I assume that it goes through the hoop. So we know this. We know that the ball was hit at 2 meters. After 1 second, it was at 5 meters. That's all I know. So, well, I'm going to get enough information for the vertex. But what it's not given here is a set of axes. So I'm going to need to make up some axes. And wherever I put them, it's going to be right. Just my equation is going to look a little different. What do I mean? Well, it will probably make sense to put the horizontal axis right on the floor. Now you may want to put it right on the top or where you hit it. That's likely a possible answer, but most people like to put it right on the floor. That's good. But what about the vertical axis? Well, I have a whole bunch of choices. I could put the vertical axis right where I hit it, or I could put the vertical axis right at the vertex, or I could put it where it hits the ground, or I could put it anywhere in between, really. But these are the two more popular choices. Now, if that was the case, then this point, my starting point, would be 0 and 2. Because at 0 time, it was at 2 meters. And my vertex would be, after 1 second, it reached 5. That makes sense. But if I pick this axis, now my starting point here would be -1 and 2. Because it happened 1 second before this. And my vertex would be 0 and 5. So I'm going to have different points for the same things, different numbers for it. So it's very important that when you do these questions, you show me your diagram. So I'm going to now show you how to solve it using this, how to solve it using that, and you see how it will be different and how it will be the same. Okay, so this is 0 and 2, and 1 and 5. And that's -1 and 2, and 0 and 5. So if my vertex was 1 and 5 and my point was 0 and 2, because I have the vertex, I'm going to use vertex form. Now I'm going to replace the h, the k, the x, and the y into the form. So y was 2, a, I don't know it yet, x was 0, h was 1, and k was 5. Once I have this, again by just using BEDMAS, and you do have to be careful, I get that -1 squared is just 1. So I get 1a. This 5, I'm going to immediately take it to the other side. So it's going to be 2 minus 5. Now some people put these two guys together, but you have to remember that these are two different terms. And you cannot put them together. So make sure that you get this 5 over to the other side. 2 minus 5 is -3, and that's a. So we got the shape. The shape is -3. It opens down, that makes sense. And then we plug it back in, and that is our model for it. Okay? If we had asked a question, which I didn't, but I'll ask it right now, well, what was the height of the ball half a second after it was hit? Then all I gotta do is just plug it in. Now because, in this case, let me bring this back, because in this case, half a second after would be positive 0.5, I plug in positive 0.5 on my formula, and I get 4.25 meters. Okay, what would happen if we pick the other ones? Well, you're going to see that I get 0 and 5, that's my h and k, my x and my y. Plug it in, and I get that my a value is -3. It's the same one as before. Does that make sense? Well, yes, the shape of the parabola did not change. I just changed the axis, but the shape would have been the same. But then my function looks a little different. -3x squared plus 5. So this x squared, because it was x minus 0, but I'm not going to write x minus 0. I'm just going to do that, and I'll let you follow those steps. So the functions look the same, but when I plug in, if I want to ask my question, answer my question, what was the height of the ball half a second after it was hit? Well, half a second after, it was -0.5, because I'm still to the left of the vertical axis. So if I plug in -5 into my equation, then I end up with exactly the same value, 4.25.